Hello everyone, Patrick Clayton here with another set of discussion post videos. Got some questions here I'm going to go over and one for you guys to try out on your own at the end of the video. So for this problem we've been asked to find the vertical asymptotes of the function x squared minus 1 over x squared minus 4x plus 3. So the way to start this problem is we're going to want to factor both the numerator and the denominator as much as we can. And the reason we're doing this is you'll see in a second we're going to have a special case scenario here that a lot of students miss when doing a problem like this. So in the numerator we have our special case factoring a squared minus b squared. We know that that factors into a plus b times a minus b, in this case x plus 1 and x minus 1. In the denominator here, we know that x squared can only come from x and x. Our second sign is positive. That means our signs will be the same, and they'll be the same as the first sign. So minus minus there. And then we need factors of 3, who, since our signs are the same, add up to 4. There's only one factor set for 3. It's 3 and 1. So here we can see the fully factored form of the function we were given, and here's where that special case comes up. Is we can see here we have two terms that we can cancel out because we have a term that's the same in the numerator and denominator. The important thing to note here is that we still have a restriction based on the x minus 1. So we know that x minus 1 cannot equal 0. So if we add 1 to both sides there, we get x cannot equal 1. And this is a mistake students make. It's typically they would consider this to be an asymptote because they've just set the denominator equal to 0. But this in fact is not an asymptote because of that cancellation being possible. There'll just be a hole in the graph at 1. So the only true asymptote we have here is based on the other. We say x minus 3 cannot equal 0. Add 3 to both sides, and we see that x cannot equal 3. So x equals 3 is our vertical asymptote for this function. Again, we won't have a value of y at x equals 1 because we'll have the hole in the graph there based on this being part of the original function, so that restriction still stays. It is not, however, an asymptote, so the only vertical asymptote would be the line x equals 3. Now to give you one for you guys to try out on your own here, go ahead and try to find all the possible vertical asymptotes of function x equals x squared minus x minus 6 divided by x squared plus 7x plus 10. Thank you.